Hey, fourth grade friends. I'm so excited to see you today. Thank you for joining me for another day of Number Corner. January is almost over. I literally cannot believe it. It's gone by so fast. And that means we're about to start February, and before we know it, it's going to be the end of the school year. And we want to make sure that you have mastered all of the fourth grade standards. So the things that we're doing during Number Corner are important, and you are responsible for your learning. So join with me today. We're going to talk about some different types of division. Before we do, let's see what our calendar marker for today is. Today is Thursday, January the 28th, and we have a 1, 2, 3, 4, 5, a pentagon. Not a regular pentagon. It's irregular, but it's still a pentagon because it has 5 sides. And we can figure out our area. Yesterday's shape had an area of 3.5. So we multiply 3.5 times 4. So essentially that's 3 times 4, which is 12, and then a half times 4. A half plus a half is a whole. Another half plus another half is another whole. So we have 12 plus 2 should be an area of 14. Let's check. 4, 8, 9, 10, 11, 12, 13. Half plus half is 14. Perfect. So we can update that on our calendar grid recording sheet. And then we have, so I'm going to write pentagon really quickly. And I'm going to write 14. And then we have our calendar collector. So even though today is Thursday, remember we had that day where we didn't have school with Miss Trammell, but you still had work to do or makeup work to do. So technically this is day 18 for our calendar collector, which means we have 54 quarters, which is 54 fourths. And that gives us a total of 13 and a half, because I looked at this number and I added 3/4 to it. I added 3 more quarters to it. So I know that I now have $13.50. We're almost done with our collection for the month. But our focus today is on division. So I would like for you to open up your calendar or your Number Corner workbooks to page 52. Our focus is going to be on number 1 for right now. And when you get there, if you can go ahead and silently read the problem to yourself, that would be awesome. I'll give you a few seconds. All right, so here's our problem. Marcos made brownies for the 6th grade dance. He arranged the brownies on a tray in a 12 by 16 array. But when he got to the dance, he had to put the brownies on 9 separate trays, 9 separate plates. If Marcos puts the same amount of brownies on each plate, how many brownies will be on the plate? Go ahead and take a second and say this problem out loud in your own words. Make sure you are referencing the key details in the problem that we need to solve it. And then think about the steps that are needed to be taken so that we can solve the problem. Okay, so hopefully you said we have brownies, 12 by 16, and we need to put those brownies on 9 plates, right? So what's the first step? We need to multiply 12 times 16. So go ahead and work that out right now. Think about a strategy that you can use to solve 12 times 16. My thought is that I know that 16 is 10 plus 6. And hopefully you know your 12 times tables. So maybe it'll be easy for you to solve it that way. Or maybe you need to draw out your array with one side it's 12 and one side is 16 and figure out your partial products. Go ahead and solve it. Right, if you needed to pause this video, I hope that you've done so. We're going to go ahead and talk about what answer you should have gotten for the problem for 12 times 16. And I'm just showing you one strategy that could be used to solve it. You could have done your partial products, or maybe you broke down the number by your understanding of place value because you know 12s, right? So 12 times 10 is 120. And then 12 times 6 is 72. So 120 plus 72 equals 192 brownies. I have 192 brownies that I need to divide into 9 separate plates. Now here's the deal. A lot of times when you're reading word problems, the word problem kind of makes a suggestion about a visual that you're seeing in your mind. So automatically when I read this, I saw 12 by 16 as an array because it says 12 by 16. If it said 12 clowns with 16 balloons in each hand, I would think equal groups. But this made me think in terms of an array. But when it says put it on 9 separate plates, that makes me think equal groups. So I'm going to draw out 9 plates here, and I'm going to draw it like my plate's going to be a square. Okay, and I want you to take a moment and do the same thing in your notebook. We need 9 plates. All right, so hopefully you have your 9 plates. And so now we need to figure out how to solve this problem. We know the total. We know how many groups. Our job is to figure out how many are going to go in each group. So how many brownies can we put on each plate? So my first step would be to, let's just put some in here. And we don't have to start by ones. Like in 3rd grade, you might have said 1 for you, 1 for you, 1 for you, 1 for you, so on. But we don't need to start by ones. We can start by a bigger number. Like maybe, can we start by 50? Can we do 50 here, 50 here, 50 here? 50? Nah, that would be way more than 192 just with 4 plates. How about 25? 25, 25, 25, 25, that's 100. 25, 25, 25, 25, that's 200. Nope. Let's go with 10. Let's put 10 in each plate and then see what we have left. Okay? So I got 10, 20, 30, 40, 50, 60, 70, 80, 90. So now, how much do I have left to go? I have 192. I'm taking 90 away, which means now I have 102. Can I go another round of 90? Absolutely I can. So let me do another 10. So we do another 10 in each category, which gives us another 90. Okay, and if we take out that 90, how much do we have left to go? Right, now we have 12 left. So how much do we want to start putting in each on each plate now? Maybe 1. 1, 1, 1, 1, 1, 1, 1, 1, 1. So now I have how many left over? I only have 3 left over. So far we have 21 on each plate with 3 left over. Remember when we talked about remainders? So we can do something with a remainder. We could be really greedy and eat the 3 and save those so we can have extra brownies for ourselves. Maybe you waste food and you throw them away. I don't know, but we could do something with a brownie. Yeah, we could cut our brownie up into fractional pieces, couldn't we? So maybe we could put, let's see, If we put a fourth in each one, that would give us one whole brownie here and one whole brownie here, but we'd still have 3/4 left. So we don't want to put a fourth in each one. What if we put maybe a third in each one? So this would give us one whole brownie. If I add a third, a third, a third, this would give us one whole brownie. And this would give us one whole brownie. So I have 21 1/3 pieces of brownie on each plate. That's if I decide I want to use each or use those last three. Maybe you don't decide that. But I just want you to know that there are different things that we can do with the remainder. We can use it, we can discard it. In some cases, we have to add one. Remember that from our last session on word problems with division? Okay, let's look at the next question. Olivia made mini pizzas for the 6th grade dance. She brought 7 trays of mini pizzas. Each tray holds 36 pizzas. The mini pizzas also had to be divided among several plates. If Olivia can put 8 pizzas on each plate, how many plates does she need? Wow. Take a second, repeat this in your own words, making sure you are paying close attention to the important details that we need to solve this problem. Yeah, 7 trays, and each one has 36 pizzas. That's what she's bringing to the dance. And now she has to cut them all up or do whatever and put 8 pieces on each plate. So, how many pizzas does she have total? What do we have to do? What's our equation here? Good. It is 7 times 36. Now, 7 times 36 is the same as saying 7 times 30 plus 6. I broke up my 36 into 30 plus 6, right? So that means I can do 7 times 30 plus I can do 7 times 6. And I'm going to put parentheses around my 7 times 30 because what's in parentheses needs to be done first. Okay? Go ahead and solve that. We know 7 times 30 because we can break up 30 into 3 times 10. So it'll be 7 times 3 times 10. 7 times 3 times 10. Some of you know what teachers are calling the add 0 rule, but I hate that rule because we're not really adding 0. We are increasing by a power of 10. So 7 times 30 is 210 plus 7 times 6 is 42. So now I have 252 pizzas. Okay, so we've done the first step. Are we done? No. Now we have to figure out how many pizzas. We need to put 8 on each plate. Okay, so how many pizzas does she need? Or how many plates does she need? So our equation now is 252. And we're going to divide that by 8. And that'll give us our plates, how many plates we need. Okay, so it looks like in this problem we know how many are in each group. And we need to figure out how many groups there are. How can we work this problem out? Let's make an estimate here. Let's start there. About how many plates do you think we'll need? Will it be more than 10? Yeah, because 10 times 8 is 50, or 10 times 8 is 80. We need more than 10. How about more than 50? Less than 50. 8 times 50 is like 400. Maybe we need half of that because we don't need 400, but we need at least 200, so maybe 25. Well, 8 times 20 is 160, and 8 times 5 is 40, so we need about 25. I would say more than 25 because 25 times 8 is, what is 25 times 8? We just went over that, right? 20 times 8, 160. 5 times 8, 40. So that's 200. So 25 times 8 is 200. Kind of like saying 25 cents, and you have 8 of them, like 8 quarters. That's $2. So we have 200. So we know we need more than 25 plates. Let's start there. I will say this problem, instead of knowing how many groups we have, now we got to figure out how many groups we have. We don't know. We just know how many are in each group. So when we know how many are in each group, there's something we can do. We can just keep taking away 8 and make a group, make a group, make a group, make a group. We can do that. It just might take a really long time. We could also already write down what we know. We know that 8 times 25, thinking about quarters, is 200. So now we have to think about how we're going to get 52. I'm going to draw out a picture here. And it kind of relates to what we've been doing because we have 8 and we want to know what our other dimension is, essentially. So what we've done so far is we said we know 8 times 25, and we'll make that 25. Might not be as proportionate as what I would like it to be. And that's 200. We need 52 more. So anything times 8 going to give us a number close to 52? Eight times 5 we know is 40. What about 8 times 6? Let's do 8 times 6, which is 48. And 200 plus 48 is 248. And 248, that means we have 4 pizzas left over. So right here, our answer looks like it is 31, remainder 4. And if I just write 31 R4, I promise you, people are going to be like, what does that even mean? Like, what is R? R means what? What are we going to do with those 4 leftover pizzas? I know you're not going to throw away 4 extra pizzas, and I know you can't eat 4 extra pizzas by yourself. So what do we need? Maybe we need a whole extra plate. And our plate's just not going to be full, right? So the answer to this problem is 31 remainder 4. But really, how many plates do we need? We need 32 plates if we're going to plate all of those pizzas. Okay? So what we kind of did today, yes, we did some division problems. Yes, they were multi-step. But we talked about 2 different types of division problems. One is partitive, and one is quotative. I'm not going to quiz you on those terms, but I do want you to recognize the difference. In one type of problem, we know how many groups we have. We don't know how many go in each group. In the other problem, we know how many are in each group. We have no clue how many groups there are. And understanding the different types of these problems are going to help you determine how you're going to solve them. So maybe you solve it when you know how many groups. Maybe you do like what we did here, and that's perfectly fine. It's an efficient way to do it. But if you know how many groups or how many are in each group, you don't know how many groups, maybe you might draw an array and use what we know about our partial quotients, partial products here, okay? So we've done a lot of work with division, guys. And like I said before, I'm not going to quiz you on the type. I just want you to recognize them. So if I were to tell you, I have 200 apples, and I want to put those 200 apples in 5 bags, do I know how many groups I have, or do I know how many are in each group? Right, I know how many groups I have. I have 5 groups, and I got to figure out how many go in each bag. What if I said I had 200 apples, and I want to separate them into groups of 6? How many groups do I have? Right, now I know how many are in each group. And knowing that is going to help you figure out the strategy that you may use to solve the problem. So thanks for participating. Tomorrow is Friday. It's the last day of January before we start some new number corner workouts. Have a great afternoon. Bye-bye.